In this video, we'll be playing with more numbers. So far, we've been able to print Hello World program in Rust. Now we're going to be exploring another thing in Rust, but we're still going to keep ourselves basic with printing. So in this exercise, what we'll be doing is we'll be playing with numbers, as the title says. So we open in terminal again and we create a new project as we explained in the previous video. Cargo, new, ex03, playing with numbers. So with our package created, we see that we have playing with numbers here, and I could just open this in terminal again. So I could open it in VS Code. Right here we have our project created for us with all our files that we're going to need. And quickly, before we even go ahead, let's just build the application to be sure everything works alright. Alright, perfect. Now if we open our main.rs file, we see that we have our main function here with just one line, print hello world. And when we run this application, the result we get is hello world printed to us, as you can see down here. Now what do we want to do? We want to play with some numbers. We saw in our one of our previous videos where we had to print the number 0, I think. Let's try to print 0 here. We see that the number 0 is printed. However, this is 0 given as a string. If we now try to print 0, Rust reports an error. You might be missing a string literal to format with. Now a string is just a sequence of characters. You have A, Z, B, X, Y, Z, and you want to make them as one. Combining this, you form a string literal. You form a string. However, in Rust, whenever we want to print anything, we cannot just print numbers, we cannot just print anything as long as it's not a string or not a string literal. So what we need to do to print this is to first provide the literal for this, and then provide the value that should stand in place of this. Now if you try to run this application, absolutely no errors, and the number 0 is still printed exactly as we had it in the previous example. Now what this does is it takes this number and replaces with this. Another thing we might want to do is we want to do some basic addition between two numbers to see if what we're going to print out is what we're expecting. So let's go to the famous 1 plus 1. 1 plus 1 as a string. Exactly 1 plus 1 is printed out to us because this is just a string. Again, it doesn't do any operation. We cannot be expecting 2 to be presented to us. However, if we produce back or if we set back our place value and provide 1 plus 1, running this is going to provide us with 2. Now this is because Rust performs the operation for us by adding 1 to 1, and the result of this operation gets placed here. One thing we can do is we could come here and we could say 1 plus 1 equals this. And what we're expecting here is that this should be calculated and provided to us here. So we have a simple calculator we can write in line, and if you really like a lot of stress, then you could try this out. So on running this, we see the result presented to us 1 plus 1 equals 2. If we come here and we change this to 17 and do 1 plus 17, what happens is 1 plus 17 equals 18. Now what are we doing? What we are doing is we are producing an operation which is going to be taken care of by Rust. So we are producing an expression which is going to be taken care of by Rust. Now what it does is it adds these two numbers and stores it in this position here. These numbers are only replaced by what we have as this place value here. The rest are what we hard code into our string literals. You may also want to change this maybe to provide your own personalized numbers outside of this. We give 1, we give 17. Now if you look at this, you see that we have 3 place values here. The first is assigned to this 1, the second is assigned to 17, and the third is assigned to this expression 1 plus 17. On running this, what you get is 1 plus 17 equals 18. Now we have seen that we can do basic addition in Rust. What else can we do? Lucky enough, we can do subtraction. Oh, that's a mistake. And the expectation we have here should be 1 minus 17 negative 16. Exactly. Another thing we can do is multiplication. Let's use 2 here. Use 3. What we're expecting is 6, right? Two times 3, 6. And lastly, which is going to come with a little bit of a trick, let's do division. 4, 2. So 4 divided by 2, our expectation should be that we get 2, right? 4 divided by 2 is 2. Now let's play a bit with an extra example. Instead of 4 divided by 2, let's produce something that is going to give us a remainder. So we use 3. 4 divided by 3, our expectations will be 1.333. We have 1. Now this is a very interesting case. Like I said, this is a very interesting case. Why do we say it's interesting? That's because our expectation from this output should be that we have 1.333. However, we have just 1. What's going on? In Rust, we have types. Everything we deal with has a type. Numbers are a type which actually have specific types assigned to them. So these are just integers. 4 is an integer, a whole number. 3 is an integer, another whole number. Negative 16 is another integer. 17 is an integer, and 1 is an integer. However, the result of the expression 4 divided by 3 is not an integer, it's a rational number. Now this is a number 1.333, and what we are expecting is that Rust should provide us with that value. However, we are not getting it. That's because Rust returns a type which is actually one of the types that we are providing here, the integer. If we are expecting to have a floating point number or a rational number, we should provide a point here. Or let's just say 0.0. Now if we look at this, Rust understands this now to be a floating point number represented by the F64 we can see here. We're not going to go into talking about this right now because we're just still playing with numbers. If we come now to 3 or 4 here, we see an I32. The I stands for integer, while the F stands for floating point. Or let's just say floating. So if you now run this application, our expected result is presented to us. Another interesting thing. Running this, we see that there's an error presented to us. A whole bunch of explanations saying that we cannot do this operation. That's because we cannot perform an operation between a type and a different type. This is a floating point number F64 and this is an integer I32. However, we are trying to divide between these two. Rust does not allow that. So whenever you have to perform an operation, we always need to make sure that they are of the same type. So if you're doing a floating point number expression with another one, you must make sure that they are of the same type to avoid these errors. So while playing with numbers, you're actually seeing some interesting horrors about Rust. With that said, we are going to conclude this video having learning how to play with numbers in strings. We also learned how to play with some basic arithmetic operations like addition, subtraction, multiplication, and division. Going forward, we'll be exploring more about numbers. Now, we have only been printing since we started this exercise. You may now be wondering, how do I create stuff? How do I do more? What can I learn more? Because it's not about printing. We don't only end at printing. In the next videos, we'll be talking about creating variables, which we're going to explain then. We're going to write longer lines of code than just the one line we've been playing with since we started. Looking forward to the next videos, guys. See you on.